Hi guys, this video explains how in C++ array pointers can be used in a way to iterate through arrays, and that explains why iterators work the way they do. Iterators were designed to mimic this kind of usage pattern, so let's look at this usage pattern. I've set up here a array of floats. This is a raw array or a C-style array, and I'm using a for loop to use a pointer to iterate through that array. There's a few ways of writing this, but I've chosen to write this in a specific way that will dovetail nicely into the iterator discussion in a moment. So PTR is pointer. That's going to point to a location within this array. See down here I've got array A. A is the pointer to the beginning of the array, and I have initialized it with 7, 2, 8, and 3. And then there's a past the end location, which would be off limits. We should never dereference a pointer there, but PTR will eventually get to that location to end the loop. I've got the indices down here, 0, 1, 2, 3 as well. So pointer is initialized to point at array element 0, the address of that location. And I loop as long as pointer has not gone past the end. So as long as pointer is not the address of a subscript 4, a subscript 4 would be an illegal index. It's the first illegal index because the maximum valid index is 3. Every iteration of the loop, I say float x is dereference pointer. So I follow pointer to obtain a float, and I'm putting it in variable x for convenience. And then I would see out x. I guess I wrote c there, but that's not an important part of this presentation. And then to move to the next location, we do pointer plus plus. That increments the pointer to point to the next location. So the way this would work is pointer would be initialized to point at index 0, which holds 7. We would print out 7. Then pointer plus plus moves pointer to point at index number 1, which holds 2. We would print out 2. Plus plus to index number 2, holding 8. Plus plus to index number 3, holding 3. Now let's focus on how this ends. Pointer plus plus will move pointer past the end. So this pointer is temporarily at a location that is not a legal place to dereference. However, the loop condition will observe that the pointer has now become equal to the address of A index 4 and stop the loop. Importantly, this star pointer dereference never happens because the loop condition is checked before executing the body of the loop, and that's why for loops work the way they do. So taking the parts of this kind of loop, we can see all of the major components of an iterator type. So to speak, iterator type is float star. This is kind of the iterator, the original iterator before iterators were even conceived. So this float star data type is the data type of a location within an array. The start location, which I called S in the previous video, is the address of array element 0. That's the first location in the array. That's a valid location in a non-empty array. The end location is the address of A4 over here. So this is the past the end location. Once we get to this location, we should stop the loop because that's not actually a valid location. We test whether we're done by comparing the pointer of where we're at to the past the end location. As long as they're not equal, we keep going. But once the location we're at is equal to the past the end location, we stop. The way that we get one element from the pointer, so the way that we go from an iterator to the element at the location of that iterator is with the dereference operator, star, used that way. And the way that we move from one location to the next location is with a pointer plus plus. Most of the time that moves us from one valid location to the next valid location. The last time it moves from the last valid location to the past the end location. So if we pull that apart, what are the essential operations that an iterator type needs to have? It needs to have a way to get a beginning location. So every container type has a begin function like this. We'll get into this in a little more detail later, but every container that supports iterators has a begin function that gives you the location of the first element in the array. We also need to be able to assign iterators so that we can assign them into variables. Likewise, we need to be able to get the end location. So every container has an end function that gives me the past the end location. We need to be able to compare two iterators to be able to decide whether the loop ends. So the equal and the not equal operators need to work. And we need to be able to get an element at the location of iter. So if iter represents a valid location, it's an iterator object that's not past the end, we need to be able to dereference it to get the element that's actually stored at that location. That's the whole point of these loops usually, is to use the elements in the container. And then we need to be able to advance to the next location. That's the plus plus operation. So we need the increment operator to work to move from one location to the next. or past the end when we're already at the last location. So every iterator type supports these. Standard vector iterator, standard list iterator supports all of these operators that allow us to have a coherent iterator type that supports all of these operations. They're implemented in different ways, though, and we'll get into that more in a different video. The way that you traverse an array is very different from the way that you traverse a linked list.